Hello everyone, my name is also Adhikari and I'm here to present the paper Embodied VR Flying Improves Spatial Orientation while Reducing Cybersickness. Let's start with an example of taking a walk in a park. Say we got out of our car and took this walk to a viewpoint. Then we know from our experience that we have a general sense of the direction in which the car is parked and how far we are from the car. This is possible because our spatial knowledge updates as we move around in our environment, and it is an automated process. And this helps us to navigate the environment efficiently and effectively. Now, let's say someone asks us to imagine that motion instead of making it in real life. Then the research shows that we're not as accurate or quick in updating our spatial knowledge as a real world walk. Now imagine the case of traveling in VR. Actual walking is not always possible in VR, and oftentimes we end up using the controller that comes in the box with the headset. Now traveling with a controller is somewhere between imagining that walk and making a real world walk, because we can still visually see where we are going, but we're not physically moving. And the research says that is still not enough. Spatial updating with controller is also not as quick as a real world travel. So what can we do about it? Previous studies show that leaning based interfaces in 2D, where you lean in the direction you want to move, provide partial body based cues. And these cues improve spatial awareness, enhance presence, immersion, enjoyment, and engagement, and it reduces motion sickness. So in this paper, we're looking at what happens when leaning based interface face is modified to have flying capabilities as well. Why even consider the case of flying? Well, with the advancement in the current technology, a virtual model of a city in VR is a reality now, and we can explore any place in the world through virtual tourism. VR games also use 3D spaces, and telepresence drone are a reality now with advancement in drone technology, and their uses is only going to increase with the time. However, to use all of these applications effectively, we need an interface that supports spatial updating. And there have been no previous studies comparing spatial updating in 3D locomotion in VR. So we conducted a user study with the following research questions. Do leaning-based interfaces improve navigational search performance compared to handheld controller for 3D locomotion? We looked at navigational search performance because we used a navigational search task in this user study. But this navigational search task was designed in a way that it critically relied on spatial updating. So we are also looking at spatial updating through this research. Further, we investigate, do leaning-based interfaces help to reduce cybersickness in 3D navigation, and how do leaning and controller-based interfaces affect the overall user experience and usability in 3D navigation. We designed a task based on previous ground-based navigational search tasks. So in this task, a user is in a dark environment that is devoid of global landmarks. And there are 16 identical boxes randomly placed in this environment, with half of them containing hidden cores. And the participants are tasked to find all the balls as quickly as possible without revisiting the boxes. Now, to collect a new ball, the participant has to visit a new box, and to visit a new box, the participant has to keep track of the areas where he or she has previously visited and looked at those box, and go to the areas where the boxes haven't been visited yet. So they need to update their spatial knowledge as they move around the environment. And we compared link-based interfaces shown in the video with a controller. And these are the results. More balls were collected when using leaning-based interface compared to controller. And as I previously mentioned, to collect more balls, they had to visit new boxes, and to visit new boxes, they had to know where the previously visited boxes were and where the new boxes were. So this indicates that but the participants had a better spatial updating when they were using leaning-based interface. Not only that, the participants traveled significantly less when they were using leaning-based interface. And one of the reasons they traveled less was they knew the direction they were coming from and they knew the direction they wanted to go towards. So they had a more efficient and effective travel path with leaning compared to controller. So all of this indicate that the participants had a better spatial updating, and that's why they performed better navigational search tasks with leaning-based interface compared to controller. When we look at the cybersickness result, leaning was less likely to cause cybersickness compared to controller when we looked at the post-trial and pre-trial data. Since this was an within subject design, we also wanted to see if there was an effect of the order in which the participants use the interfaces. Half of them use the controller first, half of them use the leaning-based interface first. And the result assures us that irrespective of the order in which they use the interface, controller is always more likely to cause motion sickness compared to leaning. So overall, um, leaning helps to mitigate some of the problems of cybersickness. And finally, we look at the task difficulty. The first result is that there is higher cognitive load with controller compared to leaning. And we believe there are two main reasons for this. The first is the leaning-based interface is in itself more intuitive, so it requires less mental effort to move with the interface itself. And the second is, as I previously mentioned, spatial updating is supposed to be an automated process. It is supposed to happen intuitively, instinctively, and it was more or less true for leaning-based interface. Whereas with a controller, it was not so. They had to actively think about the direction they were coming from and the direction they wanted to go. So it required mental effort to keep track of their travel. Now, consider a real world scenario. We're not just using, we're not just navigating, performing some secondary task while navigating, right? So when we're using an interface like leaning-based interface, it requires less mental effort. So it frees up our mind to perform the other secondary tasks that we need to do while navigating or locomoting. Whereas with a controller, it takes such a high cognitive effort to just move that it leaves little space to perform secondary tasks. So while using these interfaces for various reasons, interfaces like leaning-based interface can become more useful. When we look at the physical demand, that one is a bit interesting. When the participants used leaning based interface first, they didn't think that it required a lot of physical effort. But for the group that used the controller first and then switched to leaning, they were definitely like, yeah, it does require more physical effort to use leaning based interface compared to a controller. And we can see similar idea being mirrored in post-experiment interviews. So when we looked at the participants' answers and did a thematic analysis, they told us that Yes, controller is familiar. It requires less physical effort and less causes less fatigue, and it is faster. But leaning is more natural. It gives a feeling of almost like swimming or floating in space, and it is immersive. Therefore, it is intuitive. It is easy to learn and use. It has a better controllability. Um, On top of that, leaning helps with the motion sickness, whereas controller makes it worse. So this is what we learned from this usage study. Leaning-based interfaces compared to controller-based interfaces in 3D improve performance in navigational search task. And since this navigational search task was critically reliant in spatial updating, it also says that spatial updating is better with leaning-based interfaces. It mitigates cyber sickness, and it reduces cognitive load and provide naturalistic experience. On the downside, it can be a bit slow and can cause fatigue in the long-term use. Thank you.